Hi friends, today we are going to see about Z transform of next set of problems. First problem, Z transform of 1 by n. How will you find out Z transform of 1 by n? First we have to write the summation. What is Z transform of f of n? Z transform of a function. Summation n is equal to 0 to infinity f of n z power minus n. This is the definition of z transform of 1 by n. Sorry, z transform of f of n. Now we have to find out z transform of 1 by n. That is summation n is equal to 0 to infinity f of n is 1 by n z power minus n. Okay, so in that case, when you're substituting n is equal to 0 here, the whole term becomes infinity. Infinity plus anything can be taken as infinity. So that's why you restrict your summation to 1 to infinity. N is equal to 1 to infinity. So whenever your denominator is having 1 by n, that is the denominator is having n in your z transform, you have to take that value to be summation n is equal to 1 to infinity 1 by n z power minus n. Okay, now we have to expand this series. N is equal to 1, you have 1 by 1 z power minus 1. So z power minus 1 plus n is equal to 2, you have 1 by 2 z power minus 2 plus n is equal to 3, you have 1 by 3 z power minus 3 plus etc. up to infinity it will goes. Okay. So in that case, you have, that is, you can write this to be 1 by z plus 1 by 2 into 1 by z square plus 1 by 3 into 1 by z cube plus etc. you have. Okay, so what is this form? You have, you know that 1 plus, sorry, x plus uh, x squared by 2 plus x cube by 3 plus etc. This, what is expansion of this? This expansion is equal to minus log of 1 minus x. We already seen one problem set all the expansions. Okay, I'll give the video links if you want. You have a look on it. So x plus x squared by 2 plus x cubed by 3 plus etc. is equal to minus log of 1 minus x. But here in the place of x you have 1 by z. So when you're substituting x is equal to 1 by z, that formula becomes, that is 1 by minus log of 1 minus x is replaced by 1 by z. So which is equal to, how will you write this term? You can write this to be log of minus log of, take the LCM, z minus 1 by z. Okay, or you can write this to be the whole inverse. Here you can write this log of, you can write this z minus 1 by z, the whole inverse. You can write, this is one of the property of log, isn't it? So you have to write like this to be log of reciprocal of this z by z minus 1. Okay, and then here the region of convergence here is mod 1, that is modulus 1 by z is less than 1. Mod 1 by z is less than 1. Here itself you write this now, then you can easily get the answer. Or you can write this to be 1 is less than mod z. 1 is less than mod z. Or you can have mod z greater than 1. So the region of convergence here is mod z greater. You can write this to be mod z greater than this. You can write this to be mod z greater than 1. So this is the z transform of the function 1 by n. Okay. Whenever you're writing is a transform of some functions, you have to write along with the region of convergence. That is very, very important. Okay, and the next one, 1 by n plus 1 is a transform of 1 by n plus 1. We have to do it. Is a transform of 1 by n plus 1. Okay, so is a transform of 1 by n plus 1. The same way n is equal to 0 to infinity. You have to substitute the definition here. Okay, use the definition. 1 by f of n here is 1 by n plus 1 is it power minus n. When you're substituting n is equal to 0, this term won't go to infinity. So this is 1 by 0 plus 1 is 1 by 1. So you have 1 into is it power 0, is it power minus 0, is it power minus 0 plus 0, all the thing to be 1. So this is equal to first term is 1 plus when you're substituting n is equal to 2 here, 1 by 2 into is it power minus 2. Okay, n is equal to 1 is substituted now. So 1 by 2 into is it power minus 1 plus n is equal to 2 is substituted. 1 by 2 plus 1 is 3. So 1 by 3 into n is 2 is equal to 2 is it power minus 2 plus etc. you have. Okay. And this term here you have when you are going to apply the previous formula, you need to z here 1 by 2 is having z squared, isn't it? Or you have like this 1 by 2 into 1 by z plus 1 by 3 into 1 by z squared plus etc. Look at the previous expansion. Here 2 is there, square, 3 cube, like that you can have, then only you can apply the log formula. So for that we need 1 z here in the denominator, so multiple and divide by 1 z, and division is it is taken inside this bracket, inside this terms. Okay, so is it that is 1 by z is taken inside, is it you have to take outside, and the 1 by z is taken inside. 1 by z plus 1 by 2 into 1 by z into 1 by z, you have 1 by z squared plus 1 by 3 into 1 by z squared into 1 by z, you have 1 by z cube plus etc. Or you can write z into this term can be written as minus log of 1 minus 1 by z. Okay, and again the condition here is 1 by mod z 1 by z less than 1. Okay, so which is equal to minus z log of z minus 1 by z. Okay, or you can have to take that z to the here minus z plus z into log of this term z minus 1 by z whole power minus 1 you can have, or you can write this to be z into log of z by z minus 1. This is the expansion of z transform of 1 by n plus 1. Okay. And then next problem is we have to find out is it transform of 1 by n into n plus 1, isn't it? 1 by n into n plus 1 we have to do it. Is the transform of 1 by n into n plus 1. Here you have to apply partial fraction. Consider this term. Okay, you have to consider 1 by n into n plus 1. You can write this to be a by n plus b by n plus 1. Okay, n plus b by n plus 1. So here you have to take LCM as 1 by n plus 1. You have to write the same thing in the both the sides. Okay, compare these two terms here. When you're comparing this, which term is missing? N plus 1 is missing here. So you have to write a into n plus 1. Plus, when you're comparing these two terms, which is missing? N plus 1 is there, n is missing. So b into n you have to write it. And these two terms get cancelled. So 1 is equal to a into n plus 1 plus bn, isn't it? Now, we have to find out the constants a and b, and you have to substitute this in this equation 1. Okay, so put n when n is equal to minus 1. When n is equal, then only you can get the values to be 0. Easily find out the values of a and b. For that, you have to take easily, when you're substituting n is equal to minus 1, one term becomes 0 and we can get the value of b. In the same way, when you're substituting n is equal to 0, this get cancelled. You can get the value of a easily. You can get the value of a and b like that. Only you have to give the values for n. Okay. So when you're substituting n is equal to minus 1 here, 1 is equal, there is no n term here, a into, this becomes 0 plus b into n is minus 1, or this is not 0, so b is equal to minus 1 you have. Okay, the value of b is equal to minus 1. Minus comes here. And then when n is equal to 0, what about n is equal to 0 here? 1 is equal to a into, this term becomes a 0 plus 1 is 1 plus bn into 0. So a is equal to 1. Okay, substituting a and b values in equation 1. So substituting a and b in equation 1, we get 1 by n into n plus 1 is equal to value of a is equal to 1. So 1 by n plus value of b is equal to minus 1 by n plus 1, or you can write this to be 1 by n minus 1 by n plus 1. After that, you have to take the is a transform of these terms. Okay, so is it next one we apply is a transform on both sides. We have to apply is a transform on both sides. Then you have is a transform of 1 by n into n plus 1 is equal to, since is a transform is linear, so you can take is a transform of each and every term here. Okay, so what is a transform of 1 by n? You already know that is a transform of, we just now find out is a transform of 1 by n is log of z by z minus 1, isn't it? And then minus, here is a transform of n plus 1. Did you find n is a transform of n plus 1? Yes, that also we find it here. So is a transform of n plus 1 is z into log of z by z minus 1. If you didn't find out is a transform of n plus 1, here we just now find it. I directly substitute the value. In your exams, you have to do the procedure. That is, we already done now the same solution here. The same steps you have to write here in your problem in the solution. Okay, according to your marks, you have to write the terms. So this value is equal to, what about this term is a transform of n plus 1? We just now got the value is a transform of 1 by n plus 1 is z into log of z by z minus 1, isn't it? So this term is z into log of z by z minus 1. Okay, this is the value of n plus 1, or you can have this to be 1 minus z. Here a log of z by z minus 1 is common for these terms. So 1 minus z into log of z by z minus 1. Or you can write this to be, if you want z minus 1 to the numerator, then you can have this term to be, this is your answer. Okay, you can stop your answer here alone. But if you want further simplifying, you can write this term as log of z minus 1 by z the whole inverse, or you can write this to minus comes here. Okay, minus comes here, so minus of 1 minus z log of z minus 1 by z. Okay, or otherwise z minus 1 into log of z minus 1 by z. This way also you can write it. Either you stop your problem here itself, that is enough. Okay, if you want further simplifying, or your problem is asked to show that this result, then you have to do the steps also. Is that clear? Okay. Now, next problem is the transform of cos n pi by 2. That is, you have to apply the definition here. Is the transform of cos n pi by 2 is equal to summation n is equal to 0 to infinity. F of n here is cos n pi by 2 is power minus n. Now you have to substitute n is equal to 0 here. So cos 0 is power minus 0 plus n is equal to 1. You have to substitute cos pi by 2 is power minus 1 plus n is equal to 2 is substituted. Cos 2 pi by 2 is power minus 2 plus n is equal to 3 is substituted. Cos 3 pi by 2 is power minus 3 plus n is equal to 4 is substituted. Cos 4 pi by 2 is power minus 4 plus etc. Okay. So which is equal to, what about cos 0 value? Cos 0 is 1. Is power minus 0 is also equal to 1 plus What about cos pi by 2? Cos pi by 2 value becomes 0. And then cos 2 pi, that is pi get cancelled. Cos pi value is minus 1. So you have to substitute minus 1 into z power minus 2. This becomes 0. Okay. Plus, what about cos 3 pi by 2? Cos 3 by 2 value is equal to 0. Okay. So plus 0 plus what about cos 2 pi? Cos 2 pi is 1. How you can, that is cos n pi value is equal to minus 1 whole power n. When n is equal to 2, you get cos 2 pi, isn't it? Cos 2 pi is minus 1 whole power 2. Minus 1 whole square is 1. So plus 1 into z power minus 4 plus etc. Or you can have 1 plus into minus, you have minus. 1 minus 1 by z squared plus 1 by z power 4 plus etc. This will go up to infinity. Or what about 1 minus x plus x squared plus x minus etc. expansion, which is equal to 1 minus x whole power minus 1. What about x here? X is equal to 1 by z squared. You have to put x is equal to 1 by z squared in this expansion. This is the expansion of 1 minus 1 by z squared plus 1 by z power 4 plus etc. Okay. So you can write this to be 1 minus 1 by z squared whole power minus 1. Or you can have this z squared minus 1 divided by z squared whole power minus 1. Or you can have z squared by z squared minus 1. This is the expansion of cos n pi by 2, and here you have mod z is greater than 1. Condition here is mod z greater than 1. Next we have to find out z transform of sin n pi by 2. In the same way, you have to apply the formula. N is equal to 0 to infinity. Sin n pi by 2 z power minus n. Put n is equal to 0. You have sin 0 z power minus 0 plus sin pi by 2, okay, z power minus 1 plus n is equal to 2. You have to substitute sin 2 pi by 2 z power minus 2 plus n is equal to 3 is substituted. Sin 3 pi by 2 z power minus 3 plus n is equal to 4 is substituted. Sin 4 pi by 2 z power minus 4 plus etc. Okay. What about sin 0? Sin 0 is equal to 0. What about sin pi by 2? Sin pi by 2 is equal to minus 1. Minus 1 or plus 1? It is plus 1. Sin pi by 2 is equal to plus 1. Okay. And then here you have sin. Sorry, here you have a sin. What about sin pi? Sin pi again, that is sin n pi value is equal to 0. For n is equal to 1, 2, 3, etc. Sin pi, sin 2 pi, sin 3 pi, sin 4 pi, all the values are 0. So this time sin pi becomes 0. This is equal to 0. And what about this one? This one is sin 2 pi. This is also equal to 0. Okay. And then we have to write this value is plus 1, and here sin 3 pi by 2 is minus 1. Okay, sin 3 pi by 2 is minus 1 plus etc. Okay, you can write this to be sin of pi plus pi by 2. Okay, sin of pi plus pi by 2. Here in the pi plus pi by 2, here lies in this is pi. This is your 0 and 90 and 180, and this is 270, and this is 360 again. Okay, and here all silver tea cups, and here pi plus lies in which quadrant? Third quadrant. Third quadrant, which term is positive? Tan alone is positive, remaining terms are negative. So minus sin pi by 2, you have to write it, which is equal to minus 1. So this value is equal to minus 1. Okay, so we have this term becomes 0. So you have a z power minus 1. First term becomes 0, and next term is z power minus 1, and this is also 0, plus this term here is minus 1 into z power minus 3, plus this term becomes 0. And then what about next term? Next term will be plus 1 into z power. Okay, next term will be plus 1 into z power minus 5 plus etc. Sine 5 pi by 2 you have. Sine pi by 2, pi by 2 can be written as sine 2 pi plus pi by 2. And this lies in first quadrant. First quadrant, all the terms are positive. So here you have a plus you can have. Okay, so this becomes sine plus 1 you have. Next term, sine 5 pi by 2 becomes plus 1. So which is equal to 1 by z minus 1 by z cube plus 1 by z power 5 minus etc. Okay, and you can when you're taking 1 by z outside, this term becomes 1 minus 1 by z squared plus 1 by z power 4 minus etc. Or you can have this is equal to 1 by z into 1 minus 1 by z squared whole power minus 1. That is 1 minus x plus x squared. The previous problem we applied now the same formula you have to apply it. 1 minus x whole power minus 1 and x here is 1 by z squared. R which is equal to 1 by z into z squared minus 1 divided by z squared, or otherwise this term can be written as 1 by z into whole power minus 1 you have z squared by z squared minus 1 and this z get cancelled. So final answer is z by z squared minus 1. This is the z transform of sine n pi by 2 and the condition here is mod z is greater than 1. Okay, mod z is greater than 1. Our next problem is a transform of 1 by 2 into n plus 1 into n plus 2, isn't it? That is our next problem. Is a transform of 1 by 2 into n plus 1 into n plus 2. How will you find out is a transform of n plus 1 into n plus 2? Here this is in the denominator. If this term is in the denominator, then you have to do this. This is in the denominator. N plus 1 into n plus 2 is in the denominator. You have to go for partial fraction and you have to do the problem. But in this problem, it is in the numerator. So, you have to take this term. Is it transform of, here you have to multiply. Is it transform of 1 by 2 is taken outside. N plus 1 into n plus 2, you have to multiply this. N into n you have, first you write n plus 1 which is equal to n plus 1 into n plus 2, or otherwise 1 by 2 into is a transform of multiply this n squared plus 2n plus n, 1 is multiplied here, so 1 into n is n plus 1 into 2 is 2, or you have 1 by 2 into is a transform of n squared plus 3n plus 2. Okay, this is a transform of this term. And how will you find out is a transform of this term? Here 1 by 2 into is a transform of linear, so is a transform of n squared plus 3 into is a transform of n plus here 2 constant you can take it 2 into is a transform of 1. Okay, this way you have to write it. And how will you write that is a transform? What is a transform of n squared? Is a transform of n squared is, you have 1 by 2 into is a transform of n squared is z into z plus 1 divided by z minus 1 whole cube. This is the z transform of n squared, that you should remember. Plus 3 into what about z transform of n? Z transform of n is z by z minus 1 the whole square plus 2 into what about z transform of 1 is z by z minus 1, and which is equal to this whole square you have to simplify this. That is 1 here which is common z minus, we take z minus 1 whole square common, so we have 1 by 2 into z minus 1 the whole cube, we take it outside, and what about the remaining terms? z by you can take, okay, z by z minus 1 the whole cube you can take it. What about remaining term? Z plus 1 plus 3z into 3 into z plus 1, isn't it? Here 1 z by z minus 1 the whole cube is taken outside. Numerator you have z minus 1 alone, plus 2 into z by z minus 1 the whole cube is taken. Z minus 1 the whole squared is present here. And you have to simplify this. When you're simplifying this, I'll simplify and write it here, which is equal to this term, which is equal to z by 2 into z minus 1 the whole cube into, you have to apply the formula, z plus 1 plus 3z minus 3 plus, you have to expand this term, okay, you have to expand this term, 2 into z squared minus 2z plus 1, okay. So you have, when you're simplifying this, you have which is equal to z by 2 into z minus 1 the whole cube into z plus 1. Here you have a z plus 1 and z, here you have a I'll write it here, z plus 1 plus 3z minus 3 plus 2z squared minus 4z plus 2, isn't it? So here this term plus 3z plus z 4z plus 4z, here you have minus 4z, okay, and then here you have a 1 2 plus 1 3 minus 3 get cancelled, so remaining you have a 2z squared by 2z squared by z minus 1 the whole square. I'll write it here, which is equal to 2z squared, already one z is there, so z into 2z squared by 2 into z minus 1 the whole cube, 2 get cancelled, and z cube by z minus 1 the whole cube. This is the z transform of this one. This is a transform of 1 by 2 into n plus 1 into n plus 2 value. Okay. That's it for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. Thank you.